Just guys confirm once if the screen is clearly visible to everyone.
Yes,
Yes,
sir,
sir.
it's visible.
Fine. Okay, so today, as you all know, the topic of discussion is the topic of discussion for today's class is the elimination reaction. So we would be discussing those things. Okay, so we would be discussing over here mainly elimination reactions, elimination reactions. And what are the types of elimination reactions that we need to study? Can anyone tell me?
E1 and E2.
E1, E2.
Yes, mainly we have the E1 elimination reaction. After that, we also have the E2 elimination reaction. And one more category is there, which has been less touched in the examination, is E1 CB elimination reaction. Okay, so one by one, we'll quickly cover all these elimination reactions. But before starting this only, I would like to tell you, like in our syllabus, most of the reaction falls under the category of the E2 elimination. So in as per our syllabus, the maximum reaction that we need to study is the E2 elimination. Now, some reactions are even elimination, like the your chapter of alcohol phenol ether is going on. So in that acid catalyzed dehydration reaction is even. So we will also see that. And very few reactions are even CB1. So your priority order should be, you should thorough with the E2 first, then E1, and at last, if the time left, you should go for the E1 CB reactions. Okay. So we are proceeding first in the sequence only, E1 elimination reactions. Just 1 minute, guys. Okay. So the first reaction is E1 elimination reaction. You can keep on writing with me also. E1 elimination reaction. Now, as the name itself suggests, it is a E1 elimination reaction. So it is similar, this reaction. The process of this reaction is particularly similar to that of the SN1 reaction only. Okay. So we will write in this particular manner. E1 means unimolecular, unimolecular elimination reactions. Unimolecular elimination reactions. Okay. Like the mechanism of the E1 elimination reaction is similar to that of SN1. So its mechanism is similar to SN1. Right. Just 1 second. Okay. Now, so if its mechanism is similar to that of the SN1, so what all conclusion that we can draw from the SN1 reaction?
Two
So it's
steps.
two steps mechanism. Very good. It is also a minimum two-step. I should write like this if the carbocation rearrangement is there. So minimum two-step reaction is there. Okay. Now, so I would take one example, and with the help of it, we will understand the mechanism also. Like suppose if this is the question, let's say if this is the question, this is an alkyl bromide. Now the degree of this alkyl bromide is what, sir? 3 degree alkyl bromide is there. On this, I want to do the even elimination reactions for which the poor bases are required. So I have taken the ethanol ETOH, and in the presence of the ethanol, I am doing the heat. So in this particular reaction, even elimination reaction will go. Now, how the even elimination reaction is going to be there? Let us see the mechanism. So in the step one of the reaction, which is the RDS of this reaction also, there is loss of this halogen atom which is there. So Br minus will be lost, and since in the SN1 similar to that of SN1, this is also the RDS of the reaction, that is redetermining step of the reaction. So after this particular step, after the first step of the even elimination reaction, there is a generation of carbocation which takes place. So carbocation intermediate is there. So I can write. So since the carbocation is generated, that is why we are saying it is parallel to that of the SN1 reaction. So a carbocation intermediate is formed. Now, after that, in the step 2 of this particular reaction, there is abstraction of beta hydrogen which takes place. So this carbocation is there, sir. Now, this particular carbocation has two types of beta hydrogen. What are those beta hydrogens, sir? Let's mark this hydrogen as Ha and let's mark this hydrogen as Hb. So whatever the base you are using, let's say whatever the base that you are going to use, so that particular base is going to abstract one of the beta hydrogen. Let's say in both the cases I'm abstracting the hydrogen. Now in this case I'm abstracting this Ha hydrogen, and in the next case I'm abstracting the Hb hydrogen. So suppose when the Ha hydrogen is abstracted like this, so what product you are going to get, sir? You are going to get this type of product, right? And when you are going to abstract this Hb hydrogen like this, the base is going to abstract the Hb hydrogen, you are going to get a product like this. Okay?
Yes, sir.
Okay? So this is there. Now, so these are the two steps. Now, which will be the major product and which will be the minor product? Now you can determine the stability of product based on the hyperconjugation, right? So just check with the help of hyperconjugation, which is there.
Second one.
Second one is the major product. Now, why the second one is major product? Because this is your alkene, sir. And this alkene has how many alpha hydrogen? 2 alpha hydrogen from this position
And
and 3 alpha hydrogen from this position. So overall, this alkene has 5 alpha hydrogen. But if I ask about this particular double bond, so
9.
in this particular case, 3 from here, 3 from here, and 3 from here. Yes, you all right. It has 9 alpha hydrogen. So this will be my major product and this will be my minor product. So what we understood in even elimination reaction is that in the first step there is loss of the halogen atom. With respect to alkyl halide, I'm saying there is loss of the halogen atom, a carbocation is formed. So if a carbocation is formed, if the possible cases are there, it can rearrange also. Like in this case it was the most stable carbocation, so it does not rearrange. So rearrange can occur, and after doing the rearrangement there is loss of one of the beta hydrogen, which can lead to the formation of the products, right? So this is there. Now some more detailings regarding the even elimination also, like whatever the next step is there. Weak bases favors even elimination. This point also you should know. Weak basis favors the even elimination reaction. Okay? Like generally in your examination you are going to get these bases like alcohol, CH3OH and heat, or sometimes they will write like C2H5OH and heat. So whenever this is there na, so you should know ki, okay, these are bases which are used for the even elimination. And why the heat symbol is there in the elimination reaction? Because all eliminations are endothermic in nature. Every elimination reaction is endothermic in nature, and you know, if something is endothermic, then high temperatures favor that particular reaction. While exothermic reaction, as per the Lee-Chatelier principle, the endothermic reactions are favored by high temperature. Right? Everyone is getting my point?
Yes, sir.
Okay. Now the next point, sir, the useful point I'm telling to you, which are directly asked in our mains and NEET examination. Now the next point is the rate of even elimination reaction is directly proportional to the concentration of alkyl halide whatever you are taking raised to the power 1, and whatever base you are taking raised to the power 0. That means this is there. So that means the order of this reaction is simply what? 1. And this one is only with respect to that of the alkyl halide. It has no relation with the base amount. Right. So this is there. Now, the next point, useful point I'm telling to you. The next point with respect to even elimination. If you ask me about the reactivity of even elimination, reactivity of even elimination reactions. So even elimination reaction, you can see the carbocation is forming, and which carbocation is most stable? 3-degree carbocation. That is why 3-degree alkyl halides are far more stable. Means 3-degree alkyl halide give far more good even elimination reaction as compared to 2-degree alkyl halide as compared to 1-degree alkyl halide, right? Now, you have an idea of Sedgwick product and Hoffman product also. So, thus major product in general is the Sedgwick product over here. So the major product, I will explain the Sedgwick and Hoffman product also in the E2, but I think you guys have some idea about it. So the major product in this is the Sedgwick product in general. Okay. Sedgwick product is the major product, right? Now, the next point is that which type of solvent favors is, as you can see, sir, carbocation is generated, which is a charged species. So if you ask me about this solvent, so which type of solvent favors is polar protic solvent? The polar protic solvent favors the even elimination reaction, right? So these things are there. Now, if you ask me about the graph of the even elimination reactions also, like if you want to plot me the graph for the even elimination, which graph I'm plotting? Energy, the energy versus the progress of reaction. Progress of reaction. So since the reaction is endothermic, that means suppose reactant is over here and the product is at a higher energy. That is why I said you every elimination is a you can say, sir, endothermic in nature. So a reaction is at a lower, reactant is at lower energy and product is at higher energy. So the reaction proceeds in this particular way, like this. Okay. So this is the intermediate carbocation which is there, and this is the transition state 1, and this is the transition state 2. You can keep on noting this. Okay, so this is there. Now suppose if two types of product are forming, sir, let's say I want to plot the graph for Hoffman also and Sedgwick also. So from this intermediate only two curves will be generated. Obviously both curves will have higher energy than reactant. So let's say this is the product A and this is the product B. So which is the product A? Product A is higher energy, so it is less stable. Energy is inversely proportional to stability. So this product will be Hoffman product, and the lower one will be what, sir?
Sedgwick.
Sedgwick product. So in this way, they can give you the energy graph also. Okay. Now, one more point which is important for our JEE examination is that the kinetic isotopic effect. Kinetic isotopic effect is not applicable for E1 elimination. What is kinetic isotopic effect? That means suppose if I have taken this compound, for example, I'm saying CS3, CH, Br, CS3. On this I'm performing the elimination, and suppose in place of hydrogen, if I take the deuterium, CD, Br, and then CD3. Suppose this is there. So suppose the rate of the reaction is R1 in this case and R2 in this case. So what you will find, R1 is equals to R2. Why it is so? Because you can see in this particular thing then the RDS of this reaction. This was the RDS of the reaction, sir. So in the RDS, there is no abstraction of hydrogen. There is just only the removal of the halogen. So the halogen is same in both the cases. So that is why there is no kinetic isotopic effect which is applicable over here. Is this point is clear for everyone?
Yes, sir.
Okay. Chalo. So we will solve 1-2 question based on this, and then we will quickly proceed for the E2 elimination. Now, the thing like in your chapter of alcohol phenol ethers, this thing has been taught in your class also, like removal of alcohols in presence of acid is a even elimination. ये मैं यहाँ पे लिख दे रहा हूँ अलग से, removal of alcohol, removal I should not say, dehydration I should say, this is the wrong word, dehydration of alcohol, dehydration of alcohols under acidic condition, dehydration of alcohols under acidic conditions follow E1 elimination. Follow E1 elimination. Just 1 minute, guys. No, just I'm coming. 1 minute. Sorry for the interruption, guys. Is my voice is clear? Just confirm once.
Yes, sir.
Oh, sorry.
Yes, sir.
So dehydration of alcohols under acidic condition follow even elimination. What are the acidic conditions that are applied? You have the acid, you can have the acid H2SO4, you can have the acid S3PO4. All these will give even elimination, right? So suppose if this is the alcohol, sir, and on this particular alcohol, let's say you are treating it with H2SO4 and you are heating the compound. So which mechanism will be followed over here? Tell me quickly. E1. Because in the presence of acid, I'm doing the elimination of an alcohol. So this will be the E1 elimination. Now, what is the first step? I will solve this question step by step and then we'll proceed further. Now, this is done in most of the batches, like the dehydration of the alcohol. So please remember, this is the even elimination. So H plus is there, right? So what is the first step? OH will give electron to this H plus. After this thing will get converted to what? OH2 plus, right? After this, there is loss of this water molecule. There is loss of this water molecule. And please note, this is the RDS of the reaction. Theek. So after this, there is a carbocation generation, which is taking place over here. Now you can see outside of 5-member ring, a positive charge is there. So what thing will happen? Can anyone tell me?
Ring expansion.
Ring expansion, very good. So this was the structure over here. This bond is broken and this bond is formed. So like this is bond breaking and here the bond formation. Or I should draw the structure in this particular way, like this. Like this, positive charge comes over this carbon. Or I should draw it in a more perfect way, 6-membered ring with this and positive charge is this. Can this carbocation rearrange again? It can do, because it's still at 2 degrees, so it will ask the nearby carbon to transfer one of the hydrogens. Okay, the hydrogen is transferred and this is their positive charge. Now, what is the last step of the even elimination? Removal of the beta hydrogen. Now it has 2 beta hydrogen, let's say HA beta hydrogen and HB beta hydrogen. Tell me, removal of which hydrogen will produce a major product?
HB.
HB, very good. So this will generate the major product. So you can see I have drawn the even elimination reaction for alcohol using the mechanism. Okay. Also one thing, rate of this reaction is equals to K times of protonated alcohol. What is protonated alcohol? This is. So this is the protonated alcohol. Because the protonated alcohol is involved in the RDS. Okay. So rate of this reaction is equals to K times protonated alcohol raised to the power 1, right? Is everyone getting my point?
Yes, sir.
Yes, sir.
So these are the certain things that you should know with respect to the even elimination reaction. Okay. Now, moving on to the more important topic. Now, if you are well versed with these concepts that I've told you, you can do the questions which are required. Okay. Now, since the time is less, so we will proceed quickly for the E2 elimination reaction, from which most of the questions are being asked in our examination. Okay. So I will try to cover the details of the E2 elimination. E2 elimination. Right. Dekho, the first point, you can keep on writing with me. It is a single step concerted reaction. It is a single step concerted reaction. Just a minute. It is a single step concerted reaction. What does the word concerted reaction means?
Bond breaking and bond forming happen simultaneously.
Huh. Bond breaking, bond breaking, and bond formation. Bond breaking and bond formation. These two process takes simultaneously. Takes simultaneously. Right. Bond breaking and bond formation takes place simultaneously. The second important concept for the E2 elimination is that it is possible. It is possible in presence of strong base. In presence of strong base and high temperature. High temperature is required for every elimination reaction. So that is not the thing. But you can see for E2 elimination, so for E1 you require weak base. For E2 elimination, you require strong base. Now, what are the strong base that are available for us? Mostly they ask these three bases, which is there. The first they can write alcoholic KOH. Alcoholic KOH and heat. So basically, if you ask me about alcoholic KOH, so alcohol is there, sir, ROH is there, and KOH is there, that is KOH is there. So this OH minus eventually abstract this particular hydrogen. So alcoholic KOH is written, but the main thing which work in the elimination reaction is the alkoxide ion RO minus. So the main thing, so alcoholic KOH they will write, but in your mind it should be clear that it is not the KOH which is working as the base, it is the alkoxide ion which is working. So this is the real thing which is working as the base. The next they can write is simply NH2 minus and heat, or they can simply write R minus and heat like this. Okay, so these things are there. Now, what is the mechanism of this? The third thing, I'm dealing with the mechanism. What is the mechanism of this particular reaction? Suppose I'm writing CH3CH. Let's mark this hydrogen as H beta. या आप ऐसे लिख लो पहले. This is there CH3 CH. Let's say this is one of the hydrogen CH. After that CH, any halogen X is there, and here also it is CH2 H is there like this. Okay, and you are treating this compound in presence of alcoholic KOH, and you are doing the heating thing. Now, obviously, in the E2 elimination, what things will happen over here is that abstraction of this hydrogen and removal of this halogen takes place simultaneously. So first I will draw the product. So in this case, two products are drawn. Let's mark this hydrogen as A and let's mark this hydrogen as B. Suppose if A hydrogen is abstracted, so you will get this as the product, and suppose if the B hydrogen is abstracted, you will get this as the product. Okay, so this will be your major product again, and this will be your minor product. The stability you can determine on the basis of the hyperconjugation. Now, I'm drawing the mechanism, let's say for one of the product, let's say I'm drawing the for abstraction of mechanism for abstraction of HA hydrogen. Okay, so how this mechanism is working over here? See, this is there CH3 CH is there, after which you have a CH3. Okay. Now this hydrogen is there, this halogen is attached over here. So what thing is happening over here? Like whatever base you are using, whatever the strong base you are using, this base has started forming a bond with this hydrogen. Due to the bond, now hydrogen can form only one bond, so the base is starting forming the bond with this hydrogen. Obviously, the bond between hydrogen and carbon is going to be weak. Similarly, this halogen has started leaving the molecule. So obviously the carbon valence is getting free over here. So obviously there is bond formation which takes place over here. So this is the, you can say, this is the transition state which happens over here. So this is the, you can say, the transition state which is happening over here. So after this transition state, what is happening generally? H and X are getting removed and a double bond is getting formed over here. So after the reaction, you will get CH3, CH, double bond CH and CH3. This is the product. Similarly, you can draw the mechanism for this product also. Is this thing is clear?
Yes, sir.
Okay. Now, so this was regarding the mechanism. So it is a concerted reaction. Why the word concerted is there? You can see, sir, bond breaking. Here the bond breaking is taking place. Here you can say bond formation. Here the bond breaking. Everything is taking place simultaneously. Nothing is there like one step is taking first, other is taking second. All the steps are taking place simultaneously. Okay. Moving on to the next, fourth point. Right. Now, the rate of E2 elimination. So, rate of E2 elimination is directly proportional to the concentration of alkyl halide raised to the power 1 and the concentration of base raised to the power 1. So, what is the order of the E2 elimination? Order of the E2 elimination is 2. Right. Okay. Next thing you can write on over here is that this, if you ask about the stereochemistry of this particular reaction, if you ask me about the stereochemistry of this particular reaction, then it has certain characteristic, right? The E2 elimination is first the anti-elimination. What is the word anti-elimination is there? I will explain with the help of one example. So E2 elimination is an anti-elimination. E2 elimination is stereo-specific and E2 elimination is also stereo selective. So E2 elimination has all these criteria. Now I won't be writing the definition of this, just quickly I will explain. Stereo specific simply means that when one reactant takes part in the reaction but the other reactant cannot participate. So लिख ही देता हूं यहाँ पे, when one stereoisomer of the reactant takes part in the reaction, but other does not. With one example it will get clear to you, but other does not. First I'm writing the meaning. What is stereoselective? Stereoselective means when stereoisomeric products are formed in unequal amount. When stereoisomeric products are formed in unequal amount. Unequal amount. So this is the meaning of stereo specific and stereo selective. Now I will take one example and this will clarify your things. Dekho. Suppose you have taken like first we take a simple example. Let's say your Br is there and you are treating this compound, let's say with alcoholic KOH, and you are providing the heat. So what will happen in this particular reaction? Halogen from here and one of the beta hydrogen from here, since both sides are equal, so they will be abstracted simultaneously and this double bond is going to form. Anyone having issue in this particular question, just let me know.
No, sir.
Okay. Now, similarly, sir, if I take, let's say, this as the question, if I take this as the question, this as the question, this is a double bond, and here the bromine is there. Now, this thing has two choices, sir. What are the two choices? Either to abstract this Ha hydrogen or either to abstract this Hb hydrogen. Tell me which hydrogen will be abstracted over here, Ha or Hb?
Achieve.
HA.
We will abstract both the hydrogen. Your answer is correct, Ha and Hb. Now, suppose if you abstracted the Ha hydrogen, then in this particular case, you are going to form this thing, right? If you abstracted the Hb hydrogen, it is going to form this thing. So you can see resonance is over here. So this is the major product and this is a minor product. So you can see both these two compounds have same formula. Like whatever is the formula, both have the same chemical formula. So this is the meaning of stereoselective. See, this is the definition of stereoselective. When stereoisomeric products are formed in unequal amount. So products are forming, but they are forming in unequal amount. Okay. Now, the meaning of stereo specific, ये भी एक समझाता हूँ, देखिए. Suppose this is your reaction. This is your reaction. Let's say you have bromine over here, and let's say CH3 over here, CH3 over here also, and you have hydrogen over here, and let's say CH3 over here, and here also the hydrogen is there. Now, in this particular case, if you want to treat this compound with alcoholic QH and you are wanted to provide the heat, so in this case, the E2 elimination is an anti-elimination. That means bromine and hydrogen should be present on opposite side only. So on this carbon, no hydrogen is there. So here a double bond formation cannot take place. Adjacent to it, this is also the beta carbon and this is also the beta carbon. So, and then at this beta carbon, no reaction can take place, but at this beta carbon, the reaction can take place because this Br and H are anti with respect to each other. They have the opposite direction. So in this particular case, you can see this is the reaction, this is a final product which is going to be formed. CS3 and the two CS3 are over here.
Yes.
Right. But if I change the question in such a manner like this, the same thing is there, but I have changed the question. Now what I'm doing, I'm putting a CS3 over here, H over here, and Br over here, and H over here, and on these two, CS3 is also here and CS3 is also here. Now I'm treating it with the help of alcoholic QH. Tell me, is any reaction is going to be there?
No, sir.
No reaction. Your simple answer would be no reaction. Why no reaction is there? Because simply we all know even E2 elimination is an anti-elimination. Now H and B are of the same direction, so this thing cannot be escaped. Here, no, on this beta carbon, no hydrogen is there. On this beta carbon, hydrogen is there, but its direction is same, so no reaction is there. Okay. So that is simply the meaning of anti-elimination thing. Right? Also, so we were discussing this certain points. Now the sixth point. The sixth point is also E2 elimination. E2 elimination. In E2 elimination, kinetic isotopic effect is applicable. Kinetic isotopic effect is applicable. What does it mean? Suppose you have this halogen CS3 CHBr, and let's say you have CS3. So in this particular, you can see H and Br both has to be removed in the transition state phase. Like that is the RDS of the process, and that is the transition state of this process, and both H and Br has to be removed. So here HBr has to be removed and this compound has to be formed, which is CS3 CH double bond CH2. But if I take the deuterium, let's say CD3, then CDBr, and then again let's say CD3 is there. Now here DBr has to be removed so that this product can be formed, CD3 CD double bond CD2. So also, you know, the carbon tritium bond is more strong than carbon deuterium, than carbon hydrogen. Since all these bonds are involved in the rate determining process of this particular thing, hence this thing is going to be affecting the rate of the reaction. So if the rate of this reaction is R1 and if the rate of this reaction is R2, then obviously R1 is going to be greater than R2. More is the energy, lesser will be the rate. Is this thing is fine?
Yes, sir.
Okay. So this is there. Now some more thing like this has also been asked in our examination. In E2 elimination also, maximum time the ZF product is a major product. So this I will write clearly. Generally in E2 elimination, ZF product is the major product. ZF product is the major product, but under following conditions, Hoffman product becomes the major product. Hoffman product is the major product. So in the E2 elimination also, you have to draw the major product as the ZF product only. But under the following condition, you have to draw the Hoffman product as the major product. The most important of it, I'm telling, in presence of bulky base. In presence of bulky base. What is the bulky base? This R, let's say carbon R O minus, and heat you are doing. So this is a bulky base. Now, why the E2 eliminates, why the Hoffman product is a major product? The best example of this particular thing is the tertiary butoxide. CS3, CS3. Here also it is CS3 and then O minus. So if you heat the compound with this particular base, so you are going to get the Hoffman product as the major product. Let us take one example. Suppose CS3, CH, Br, then CH2, CH3 is there. I'm marking this hydrogen as A and I'm marking this hydrogen as B. Now I'm treating this compound in the presence of alcoholic KOH. So if I'm treating the compound in alcoholic KOH, this is a normal base. So the ZJ product is the major product. So in this particular case, you will get the product as CS3CH double bond CH and CH3. But on the same compound, sir, if I took this as the base, tertiary butoxide as the base, and I'm doing the heating thing. So what you are going to see, this tertiary butoxide, it is very difficult for the tertiary butoxide to approach this particular hydrogen due to the steric hindrance which is provided. So what does tertiary butoxide do? It is easy for the tertiary butoxide to approach this hydrogen, as this hydrogen is not facing so much steric hindrance as this particular A hydrogen was abstracting. So this tertiary butoxide will abstract the B hydrogen, and this will be your major product. CH2 double bond CH, CH2 and CH3. This. So in this case, this is the major product, and in this case, this is a major. Right. So if you have understood, anyone having difficulty in this concept?
No, sir.
Okay, so if you have understood the question, then please solve this particular question. Let's say Br is there, this thing is there. Now, first I'm doing the reaction in presence of CS3OH and heat. What is the product A? Then I'm doing the reaction in presence of alcoholic KOH and heat. What is the product? And after this, I'm doing the reaction in presence of tertiary butoxide and heat. What is the product C? You have 1 minute time, just think over it quickly. Then I will tell the answer. Done, guys?
Yes, sir.
Yes.
Okay, so let us first do with the tertiary butoxide first. So this is the hydrogen. So all these beta 1 position, beta 2 position, and beta 3 position, all are these beta hydrogens. The least crowded is this beta 3. So with the tertiary butoxide, here a double bond will form. So the product C should be this, right? With alcoholic KOH, this should be your major product, right? And with respect to CS3OH, you have to first form a carbocation. So let us form a carbocation. So this carbocation is generated. Now this carbocation will rearrange to this particular position to get converted to the 3 degree. Okay, so this is the carbocation which is generated. Now the abstraction of beta hydrogen will take place. So obviously this beta hydrogen will be abstracted so that the alkene which is formed is the major one. So like this it is formed. So in this case, the product A and product B are exactly same. Like this. Okay. Also, one more case, like I'm telling you, this particular condition generally need to elimination. Sedgwick product is the major product, but under the following condition, Hoffman product becomes the major product. So the first condition is when the base is very much bulky. The second condition that you should remember with respect to this chapter is that in presence of crowding on gamma position of leaving group. So this you can write in presence of crowding on gamma positions of the leaving group. Now, what is this particular case? देखो, suppose if this is your question, right? If Br is there, right? So two beta hydrogens are there. Let us mark this hydrogen as Ha, and this is also Hb. So it is clear to me that, okay, sir, if you use the tertiary butoxide thing which you are telling, so in this case, Hb will be abstracted and the major product should be this, right? No issue in this. But in this question, even if you use the alcoholic KOH and you are providing the heat, then also the product is same. This you should remember. Why? Because you have provided so much crowding to the alcoholic KOH also that it has become difficult for this small group also to approach this particular hydrogen. So in this particular case, this is the major product which is there. Okay. So they can create a good question in the means also, like in which of the following reaction Hoffman and Sedgwick product are same. Sorry, in which of the following reaction bulky base and alcoholic KOH is giving the same product. So this can be a potential question also. Right? Anyone having doubt in this?
No, sir.
Yes, sir.
Okay. Okay. Some more points we will discuss. One last reaction is there. That is the E1CB reaction, although it is not important for so much important like the previous reactions were there. But quickly we will see the mechanism of this. Not the mechanism, just quickly we will go through this particular thing. The last reaction is E1CB reaction, right? So E1CB stands for unimolecular unimolecular. CB stands for conjugate base, unimolecular conjugate base elimination reaction. Right. This is the meaning of E1CB elimination. Now, what is the condition for the E1CB elimination? What are the conditions for it? The conditions for it is the first, beta hydrogen of leaving group should be acidic. Should be acidic. Second condition is that it is more favorable. It is more favorable in case of poor living group. In case of poor living group. Let us take one example. Suppose sorry. Suppose this is your question. Right, and suppose the fluorine thing is there. So now this thing is there, sir. So you can see this C double bond O is there. So this particular hydrogen which is present over here, the next carbon to this is the alpha carbon and this is the beta carbon which is there. So you can see this alpha carbon which is there. Just a minute, guys. So what I was saying is that this is my leaving group which is there. So fluorine is the leaving group which is over here. And we all know fluorine is which type of leaving group? Poor
Poor.
living group. The carbon which is directly attached, this is the alpha carbon, fine. Now this is the beta carbon which is there, and beta carbon is attached to a minus M group. So this makes the hydrogen of this beta carbon as what? Acidic. So it is fulfilling all these conditions. Poor living group and beta hydrogen is acidic. So once you will treat this compound with, let's say, strong base and heat, so the elimination reaction which is going to be there is this particular thing only, but the mechanism which will be followed over here is E1CB elimination reaction. And the mechanism is not important, just I'm saying to you this is the thing which is there. If you want the mechanism, then you can think in this particular way. It is a two-step mechanism also, like quickly I will tell. Like in the step one, the base abstract this acidic hydrogen. Okay, so the base which is whichever is you are using, so this hydrogen is there. So in the presence of the base, this acidic hydrogen is abstracted. Fine, I'm generating a carbon ion over here, this F minus, and this is there. So in the first step, the carbon ion has been generated. Now in the step two, what is going to be happening is that this carbon ion is going to do the removal of the fluorine atom. So this carbon ion is there, and this is going to do like this, and this fluorine is going to be removed. And this is the RDS of the reaction. So finally, you are getting this thing as the product, right? So if you ask me about the rate of this particular reaction, so rate of this particular reaction will be K times. Now this was the acid. Suppose this is the acid. So on the removal of the acid, suppose if this is the acid, so by removal of one of the hydrogen, what we get is a conjugate base. So if you remove the like H2O, suppose is the acid, H2O is the acid. So what will be its conjugate base? OH minus. Suppose this is the acidic hydrogen. So if you remove this hydrogen, you will get a conjugate base. So rate of this reaction is simply equals to conjugate base concentration, which is this raised to the power 1. That is why the reaction is known as E1CB elimination. Right. This is there. But if you do the chemical kinetics over here, so what you will get, the rate of this particular reaction will be equals to K times concentration of the alkyl halide and concentration of the base. So if you ask me in terms of alkyl halide and base, then this reaction is of the order 2. But if you ask me in terms of the conjugate base, this reaction is with respect to the power 1. Right. So this is the concept of the E1CB elimination reaction. Anyone having doubt in this, they can ask. Anyone having doubt in this?
No, sir.
Okay. So this was the overall summary of the elimination reaction in which we have covered E1CB, E2 elimination in detail, and E1 elimination also. Right. So you can practice the question based on this from our module. And if any doubt is there, you can pose the doubt on the DeepL and you can let me know also. Right. Those who are not having doubt, they can leave the class also.
Thank you, sir.
Avni, you have doubt? Avni? Charan, you have doubt?
Yeah, I have a doubt, sir.
Yeah, just please tell me.
Sir, in E2 reaction, where you explained when you were talking about the rate of hydrogen, deuterium, and deuterium, could you go to that point?
You want me to explain that again?
No, sir. I just have a doubt in the like order.
Okay.
Yeah, this one.
Hmm.
So you told R1 is greater than R2, right?
Yes.
So shouldn't CH be the most like fastest?
So if it is fastest, then its rate is also fastest, no?
Yeah. So why do you keep CT as greater?
No, this was the order of the bond energy which I told.
Oh, okay.
This is bond energy data.
Okay,
So
okay.
bond energy for CT is highest, that is why its rate is lowest.
Okay.
Got my point?
Yes, sir. Yes, sir.
Okay.
Thank you, sir.
Okay. Okay. Okay, so we are ending the meeting.